Let's start. So yes, this part. So this is the diagram of the whole components of the computer system. This part is your central processing unit, that is consist of a program counter and register. This is the memory unit. Okay.
Register, yes, sir.
This is the memory unit. This is ALU. So it's used arithmetic logic unit. It's used plus minus any mathematical operation you perform, that's done by the ALU. Okay.
Yes, sir.
So your CPU consists of the three things: a program counter, arithmetic logic units, registers, and there's one more thing. It's not depicted in this figure, but that is a CU or control unit. Okay.
All right. Mm-hmm.
So today we discuss with these four things: a program counter, registers, arithmetic logic units, and control units. Okay. So once
All right, sir.
once we finish the CPU things, then we move to this memory things. That is the main memory. Here your RAM and your ROM chip. Okay. So we discuss it in next session maybe. But today we go with this CPU, central processing unit. Okay. Okay. So the topic for the today is the CPU, turbo boostings, and hyperthreading. And these two things, these two are the advanced thing in the CPU. Means these are the facility available in the modern processors. We discuss with these two things too. Okay. So once you, if you go in your computer system and open your task manager and go on the CPU section, these things shown to you. This is the company name of the CPU. So this is it. This is the i3 processor. Okay. And this is a model number. And this is the important number, one important number. That is 2.00 gigahertz. This is the one type of CPU. Okay. This is here another CPU is shown. It's again, its speed is 3.90 gigahertz. Yesterday we discussed what is the meaning of gigahertz. The meaning of gigahertz is 1, and after 1, how many zeros?
9 zeros.
9 zeros. Good. So 3, 3, 6, and these numbers. So it means 2.00 gigahertz means this number. This much instructions per second. So this CPU, this type of CPU that is shown in the left side can execute this much instructions per second. And on the right hand side, this CPU can execute
3 billion.
And then 8 zeros.
9 billion.
Okay. So if you multiply 3.9 with 1 up and then 9 zeros, that's this number. Okay. So this CPU can execute this much instructions per second. Okay. So this is the one thing you so this is the one thing what you see when you open your task manager. Now go with this here on the bottom side. This is your utilization, CPU utilization. Here you can see this is 16% CPU utilization. Number of processes or programs that currently executed in execution phase or suspended phase is 197. Okay. And please see this speed. This is 1.99 gigahertz. Okay. And please come here. See what is the speed here?
1.8 gigahertz.
Yes. And see, here the speed is written 2.00 gigahertz and the speed is 1.9 gigahertz. 1.99. That is approximately equals to 2. Here the speed is written is 3.90, but the speed is 1.08.
1.8.
So this is the standard, this is the maximum speed written here. And this is the current speed of your CPU. Okay. Please remember these two things here. This is Here the speed is same to the max speed, but here the speed is different to the maximum possible speed.
That's
So that is the one thing. Come here. See, this is the course, means number of CPU. Okay. Here it's 2, and here again it's 2.
it's 2.
But number of logical processor is,
4.
remember this thing again. Okay. Although your computer has only 2 cores, 2 physical CPU, 4 means physical CPU. Okay. 4 means physical CPU. Means these number of CPU, these much CPU installed in your system. That is your cores. But the logical processors means number of instructions. Okay, one instruction goes to the one CPU at a time. Okay.
Yeah.
So please try to find here how many instructions this CPU can execute.
4.
4. Yes, because although physically only 2 CPU available, but logically we have 4 CPU.
4.
So this system, this particular system can execute 4 instructions per second, and this is comes through the technology named as hyperthreading. Okay. This is hyperthreading. And what you call this thing? See the difference between this this speed and this speed. This is turbo boosting. Okay. In the future slides, you can see what is the meaning of this turbo boosting. But for the time being, here you just remember this thing. In this type of this CPU, the CPU shown on the left side, there is no turbo boosting available. So the maximum speed is your CPU's speed at any point of the time. Okay. Here the turbo boosting is available. The meaning is this: maximum speed is although 3.90 gigahertz, but current speed is 1.08 gigahertz. And if it requires, if the system feels that you need more computation, so this speed dynamically increase to up to 3.9 gigahertz. Okay. In turbo boosting, but here this speed is always 1.99 gigahertz, neither increase or not decrease. Okay. Okay.
Yes, all right.
Good. And here 3 more things. There is three cache memory, L1, L2, and L3. When we discuss about the memory, then we discuss about the cache memory. But please see in the task manager, it shows you that L1 cache is 128 kilobyte, L2 cache is 512 kilobyte, and L3 cache is 3.0 megabyte. So it's just in the increasing order. Okay. Yeah. So the smallest one is the L1 cache, and then L2 cache, and then L3 cache.
Yeah, L3.
Yes. Go. So next slide. Okay, so base speed of the CPU, like in the previous diagram, it's 2.0 gigahertz. This is known as the base speed, means maximum possible speed. Like here, this is the base speed. Okay. So if the turbo boosting is available, if there is turbo boosting, current speed is less or equal to base speed. Yes or no?
With turbo boosting, the current speed is equal to base speed. Yes.
If the load is less, the speed is down. As the load increases, the speed increases up to the base speed, not more than the base speed. So base speed is the maximum achievable speed. But if the turbo boosting is not available, your current speed is always equal to base speed.
Base speed.
Okay. So now this is the concept of base speed. Now the cores. Number of independent central processing units in a chip is your core. Here it's 2 in both left and right in the previous diagram. Number of cores is 2. What is the meaning of logical processors? This is the definition. Logical cores
Logical.
are numbers of physical cores times the number of threads that can run on each core through the use of hyperthreading technology. Okay, so you have two cores, but these two cores are divided into two logical processor, and this is again divided into two. So total becomes 4. Yeah. And then the cache memory, that is L1, L2, L3 cache, and size is again in increasing order. Okay.
Yeah.
So these are some examples from the Intel's web page, and the details is again the same. Here, if you see, okay, can you hear the turbo boosting available or not?
Yes, turbo boosting is available.
Yes. If this speed is different, then the turbo boosting available. So in all these 4 CPUs, the turbo boosting is available. Okay. So what is turbo boosting, and what is the benefit of turbo boosting? So suppose you are just suppose just that your CPU has the speed of 2.0 gigahertz, just 2 gigahertz. It means it can execute
billion instructions per second.
Yes. Good. Now, if you are just open your computer and just sit idle, you are not using your computer. How many instructions you are giving to the computer? Only 4 or 5 or 0? Yes or no? If you are yes, if you are typing in a Word or Word or PowerPoint something, maybe 1,000 instructions you are giving in each second, maybe, but you're not going to reach up to this much instruction per second. Yes or no?
No.
In normal scenario.
No.
Yeah. But if you are using some like video playing or some computation intensive program things, then you need more speed. Yes or no?
Yes, you need more speed.
Yeah. So if your CPU is always working on this speed, 2.0 gigahertz, this gigahertz means the frequency, number of instructions per second. That is known as the frequency. Okay. So if the frequency is high and it's always high, then it consumes more power.
Yes.
And it generates more heat also, because if it consumes more power, then it generates more heat. Yes or no?
Yes.
So the solution comes in the form of the turbo boosting. That is, when you need more speed, the frequency increase. Otherwise, the frequency is down. Okay. So this is dynamic scaling. As you need more speed, the frequency is increasing. Your computer's CPU speed is increasing up to a certain threshold, of course. And when you need less computation power, your speed is down. That is known as the dynamic scaling. As you require, you get. So benefit of turbo boosting is that this, in the normal scenario, the power consumption is reduced. And since the power consumption is reduced, less heat generated.
Heat generated. Yes, sir.
Good. Any questions?
No, straightforward.
Okay.
Wait, I was answering the quizzes yesterday. I think it was the second quiz. The last question with those two computers.
Oh, yeah. Yes.
And
I will come on that question. Don't worry.
All right.
Okay. I remember that question. Okay. So what is hyperthreading? So if the hyperthreading is not there, you have a single core, that is a physical CPU. You provide one instruction and the result comes. Okay.
Yes.
That is without hyperthreading. Again, it's just straightforward. With hyperthreading, you have a single core. not 2 core, single core. But this single core is divided to the 2 logical
processors.
Yes. So now you can, since you have 2 units, you can give 2 instructions and output, you get 2 results. So in the same time, while this without hyperthreading, you can execute one instruction, uh, only one instruction. Here you can execute 2 instructions. Okay. So basically, with hyperthreading, you double the number of double the performance of your computer. Okay.
Yes, sir.
Good. Now again, so what are the components of the computer? CPU can basically have these 3 things: memory units, control units, and arithmetic and logic units. And see again, the CPU is just a chip on your computer, and this chip has memory unit, control unit, and arithmetic and logical units put it in a single chip, that is a single IC. Okay. And this,
Yes, sir.
on this memory unit, you have just registers and cache memory. Please remember these 2 things. Registers and cache memory both stay inside your CPU. Okay.
Yes, sir.
Yes, please remember this thing. Registers and cache memory are inside your CPU. Okay, I think. Okay, how the CPU works?
Start.
So, see, your your program is just a line by line instructions. Okay, it's
Yes,
just
sir.
a line by line instruction stored in a single file or maybe multiple files. When this computer you start executing a particular program, it reads the first instruction. Okay, then it control unit decode that instruction, the meaning of that instruction. Suppose you say that please print this thing, print hello on the screen. So it's just read this instruction from here and then try to decode it. What is the meaning of this particular thing? It decode the instruction and then execute that instruction. So when executing this instruction, it just printing this hello on your terminal or screen, and then it again go to the next instruction, read it.
The same process happens again.
Same process again and again, unless or until it not receive any interrupt. So after each instruction, it check is there any interrupt. Suppose you just press your key, shutdown key. So that is the interrupt. After executing this particular instruction, it read the interrupt, and if there is any interrupt, execute that interrupt. Okay. And once this program finished, your CPU halts. Okay. So that's the working of the CPU. Any question?
CPU.
Yeah, working of CPU.
No, it's straightforward.
Okay, so I think this is last. Okay, what do you mean by number of cores? So that is the number of physical CPU available on your system. That is the number of core. Okay. Okay.
Hello? Yes, sir. Here you go.
Please reply. What do you mean by number of threads? Your answer, please.
Number of threads is the amount of this processes.
That is the number of instruction you can execute, or you can say
number of
logical processor, number of logical processors. Okay, so you have 2 cores, but due to the hyperthreading, number of logical processors become 4. Okay, so that is the meaning of number of threads. A maximum number of instruction you can execute in a single point of the time. That is the number of threads. Okay, what do you mean by processor base frequency?
The base frequency. I could give an example for this question.
Okay, please give.
The base frequency is basically if my computer is the max frequency is 3. Base frequency could be like a 1 or a 2, was literally the lowest frequency. And if by chance I doing more things on the computer, it's going to need more. It's going to basically frequency is going to increase to the max frequency, which is 3
Hello. Okay. Uh, so where am I? I think we are discussing about this base frequency. Yes. So Mark, what is the base frequency?
Yeah, the base frequency is basically the less frequency of the computer. Like if I'm idle or not doing anything, compared to the max frequency. Like I say, if my computer is 3 gigahertz and I'm not doing anything really, power consuming or anything like that, then the base frequency will probably be 1. But if I'm doing like video editing or gaming or stuff like that, then it will move from the base frequency and go to the max frequency, which is the 3 gigahertz.
Yes. And what is turbo boosting?
Turbo boosting is basically increasing my speed of my computer by increasing the speed of the computer, but at the same time using less power. So using less power. So using less power and less heat. Hello.
Hello. Hello.
Hello.
Wait, Mark, just wait, please.
All right.
Yes. Yes, Mark. So please. So, so I already defined what is turbo boosting or hyperthreading and max turbo boost frequency. Basically, the turbo boosting is that is what is the problem? That is the speed on demand. When you need more power, computing power, your processor's speed increase, and when you need less computation, the processor's speed is down, and that's reduce the power consumption and heat generation. So that's it. I have some questions from the. Let me finish this thing. From here. So this is from the quiz 1. There are some questions in the quiz 1 that I not discuss. So today in this session, I discuss those questions. Okay. So, Mark.
Yes, sir.
Which of the following is not an input device?
I'm going to my quiz. This is not an input device.
Yes. So display is an output device. It's not an input device. And the rest 3 are the input devices. Okay. So the correct answer is display. And question number 2. From the first generation to the 5th generation of the computer's speed. So what about the speed? It increases or decreases?
Speed increases.
Speed increases, and the size? What about the size? From the first generation to the 5th generation? Decreases. So it increases and decreases. So option C is the correct one. Okay. Move to the question number 3. What is the correct order in terms of their appearance? So which one is the first? Which of the following is made the first in appearance? Vacuum tubes, and then
yes, the vacuum tubes, and then the transistors, then the integrated circuit, and then the microprocessor.
Integrated circuit, then the microprocessors. So this one, D. Vacuum tube, transistors, integrated circuits, and this is option D.
Microprocessor.
Yes. So option D is the correct one. Okay. Let's move to these 2 questions. Okay. Can you remember how to solve this question?
Those are the thing. I never didn't come. I couldn't make it the first class, so the binary I never actually learned how to do the binary.
So I just give you the idea how you can solve this problem. 1 0 1 0 0 1. Okay. So solve like this. This is each place has its own value. So this has one value, that is 2, 4, 8, 16, and 32. Okay. So this unit last digits has the unit value 1. Second bit has the value 2. Third one 4. Fourth one 8. Fifth one 16. Sixth one 32. Okay.
16,
so
32.
Get the point? This is the simplest method.
And multiply them and then add them up, or
You just yes. So here, this one, here it's become 1. So each place where the value is 1, just go to the above value and add it. So here it's 1. So put this value here, comes 1. Again, where is the 1? At this place. So take this 8 value and put it here. Okay. Again, the next one is here. So it's correspond to 32. Put it here. So what is the next value? What add it? 32 plus 8, 40. 40 plus 1, it's become 41. Get the point? So correct answer here is 41. Okay.
41. You know, I ain't seeing no visuals, sir, following from my quiz.
Yes, this is from the quiz only. Okay. So
no, I mean as in on your actual screen though.
You can't see my screen?
I ain't seeing your screen, this is the thing. No, I only hear audio.
Wait. Screen are not visible. Let me check. Oh. Now you can see it?
Yeah, I see it now.
Oh, so sorry about that. Let me solve it again if you since you are not able to see this thing. Okay, and let me change the color. So I am saying this thing. You have to convert this number 1 0 1 0 0 1. This in the binary system. You have to convert it to the decimal system. So the simplest way of doing this thing is this. So each place has its own value. Okay, value. This value is like this. This place has the value 1. This place has the value 2. This place has the value 4. This one is 8, 16, and 32. Okay.
Mm-hmm.
So each place has its own value. And okay, so how to convert to this thing in the decimals? Here, there's the one. What is the corresponding value here on the top?
1.
Put it here. What is the next one here? What is the f of value? 8.
That is 8.
Yeah. And next one is here. This
32.
value 32. And then add these three things. What is the value?
And 41.
Yes, 41. Okay. Let me take this example. This one. Okay. In between,
Mm-hmm.
let me clear one more thing for you. How this values comes, if you ask. So it's like this. 2's power 0. This value is 1. It's a mathematics. If you want, you can calculate. Otherwise, just remember 2 to the power 1 means multiply 2 1 times, and that is 2. Next is 2 to the power 2. Its place value is 4. 2 multiplied by 2. So 4. Next one is the 2 to the power 3. The value is 8. Means 2 multiplied by 2 multiplied by 2. So it's 8. Next one is 2 to the power 4. So multiply 2 4 times, like 2 to 2 to 2 to 2. What is the value?
2 times 2
16.
times 3 times 2. 16.
Next one is 2 to the power 5, and next value is 32. So if you, it's just the 2's table, except this one, 2 to the 4, then 8, 4 multiplied by 2, 8, 8 multiplied by 2, 16, 16 multiplied by 2 is 32. Next one is 64, like this one. Okay.
Mhm.
Let me come with another example. Suppose this number. What is the decimal value corresponding to this binary number? So to calculate it, what is the place value of this place? Is 1.
Would be 1.
This 2. This
1,
one
2, 4.
4. This one 8. Okay.
4.
And for
8.
each one
Just the 1 and
in the
8.
binary, yeah, 8 plus 1, and that's 9.
9.
Get the point? Get the point?
Yeah, I understand.
Yes. Okay. Take another example. 1101. How you calculate this thing?
The 1 gonna be 1. The third one
Yes.
gonna be 4, and the fourth one gonna be 8.
Yes. So 8 plus 4, 12 plus 1, it's 13. Okay.
30.
So to solve this problem, I just give you as exercise at your means in your free time. Just try to convert these all the 4 numbers to their corresponding decimal number. Okay. Convert these numbers to decimal number, and
Yes.
one among these 4 options must be the 72. Okay. And in tomorrow's session, I will
All right, sir.
I will give you the idea how to convert the decimal to binary. Okay.
All right.
Good. Okay. Come to the next question. Here. Which of the following is not an output device?
The mouse is not output device.
Yes, mouse is an input device, and rest are these two and this one. This total are the output devices. Okay. Question number 7. Name of the first electronic general purpose computer is.
I think that's the ENA.
Yes. C option. Uh, which of the following is not the benefit of turbo boosting? Next question. Increase the increase. Okay.
Increase in processing power.
Yeah, that's. But let's. In context of the turbo boosting, the power consumption reduced. Yes. So means that is this statement is true.
Yes.
Power consumption reduced, and if the power consumption reduced, heat generation is also reduced. So that's also again a true statement. Then dynamic frequency management, that is the definition of turbo boosting. So increase in processing power, that's the false. This is the false statement. So since in the questions I put the not, so this one is the answer. Okay. Which of the following are components of the central processing unit or CPU?
All of the above.
All of the above, yes. Registers and ALU and control unit. Anything else is also the part of your CPU?
The CPU, the registers, the ALU, the control unit.
There's one more thing. Your cache memory.
Registers. Yeah, the cache memory.
Yeah, L1, L2, and L3. When you open your task manager and go to the CPU sections, you can see these are much information. So registers and cache, these two are the memory thing. These are two are the memory thing, and one is the LU and a control unit. So these three things is the part of your CPU: memory unit, and it consists of your registers and cache memory. Then second one is your arithmetic logic unit, ALU, responsible for all the mathematical operations like addition, subtraction, division, multiplication, or comparison. Any mathematical operations is performed by your arithmetic logic units. And third one is control unit. This is responsible for decoding the things and controlling the overall monitoring of your CPU. Okay.
Yes, sir.
So any other question?
No, that's it.
I remember.
Remember the question about?
I remember. I remember. On tomorrow's slide, I put that questions where I give this question. There were two hypothetical processors with something turbo boostings and hyperthreading. One is with like something like that. So tomorrow I put those things in the slide, and then
Yeah.
Okay. Any other thing, Mike?
All right, sir.
Okay.
No, that's it.
Okay, so read the slides, questions, and if you have any doubt, please ask me. Tomorrow is no session.
I know.
Saturday and Sunday is no session. On Monday, I have session. I will share you the ID details on WhatsApp. And if you have any question in meantime, on Saturday or Sunday, you are studying, please WhatsApp me. Okay.
So till Monday's class then.
Till Monday? Yeah, next class is on Monday. Okay.
All right, sir.
Yes.
Yeah.
Okay. Thanks.